Yeah. Nice. Yes.
So good evening all. My name is Madan Karthisan. I am working as a tech lead in Object Automation System Solutions Private Limited. So thank you for coming for this tech meet. So what is a tech meet? So this tech meet happens every week, every month, last Saturday. So it is of 2 hours and 2 hours duration. So where we invite people from various industries, professors, students. So today I thank SRM professors. They come from all the way from Amapuram, and also we have students from ITech, Vegamanda ITech Engineering College, from Gopichiri Kolyam, Wales University students, and also we have students from SRM Katangaltu. So thanks for coming, man. Thanks students for joining for this tech meet. So I'll first briefly introduce about what organization does. I have a profile with me. I'll explain this profile. So this is our development center in Chennai. So our headquarters is in California. Our CEO is Mr. Karasan Narayanasamy. He is the president of Open Power Foundation. So it is a non-profit organization from IBM. So mainly three things we do. So we do research, solution development, and establishing tech centers of excellence. So these are the three things we do. These things we do with the help of global partners. We are tied up with many global partners like Microsoft, Dell, HP. So with the help of those partners, we provide AI and chip design solutions. So currently now data, AI, chip design, quantum computing. So these are the famous topics. So we focus on chip design and AI. As I said, Mr. Ganesan Narayanasamy is the president of the Open Power Foundation. It is a non-profit organization from IBM. So who will be benefited from this Open Power Foundation? So students, working professionals, professors, they can become a member of this Open Power Foundation. So what is the mainly the EC students and triple E students? So what they do, this is related to chip design. So like in the colleges, we need to procure soft like a lot of things like Cadence, Synapses. These are all costly tools. So instead of going for the costly tools, we can by becoming a member of this open source foundation, you can access open source tools. So by using the open source tools, we can create these are things we can top three things we can create. So my chip design team members will explain further on this. So this is the I'm just giving a brief introduction about Open Power Foundation. So open is nothing but open source. The power stands for the architecture. It is a group of processors developed by IBM. So these are the things you can do with the help of becoming a member of Open Power Foundation. So people who are in chip design, triple E students, EC students, they will be benefited by becoming a member of this Open Power Foundation. Okay. So now if you can see here, so our company started in 1996. See, we started by doing Unix projects. Then we moved to high performance computing. So what is HPC? Like we have data. We want to process data efficiently. So for this we need to do parallel processing. So parallel processing is because of HPC, high performance computing. That we do from 999. From 2011, we are doing on AI. Now from 2017, we are focusing on chip design. In addition to all these things, we are focusing on chip design since 2017. So with three things we give importance: the quality, technology solutions, and client relationships. So among the five verticals, I will explain about the last one since most of the audience are students and professors. So what do you do with respect to what are the things we offer to universities and colleges? So we set up center of excellence. So what is a center of excellence? For example, in universities and colleges, they require hardware, software. Like for example, AI, data science, all these things, they require software, hardware. So on behalf of universities and colleges, we go to the vendors like HP, Dell. We procure hardware, software in by what do you call it, the best prices, and we sell them. We set them center of excellence. For example, in Shastra University, Tanjavur, we have set up a center of excellence by buying them server. So they are using as IBM server, which we are establishing Shastra University, Tanjavur. Then FDPs. We regularly conduct faculty development programs. So there is a gap between the what industry needs and the academia, what the university or the colleges provide. So for this, and also some of the courses have recently just come. So for this, we provide training for faculties. So this is a FDP. Generally, it will be like 3 day FDP program. One is now it's quantum computing. So we also provide all these things: cloud, AI, quantum. These are three things. Cloud in the sense, all the cloud, Microsoft Azure, AWS, and GCP, Google Cloud Platform. We are partners of Microsoft. Then we conduct training programs. So like like if people are here for internship. So now we know by university norms we have to do mandatory internships. So for them people come. So even for SRM also, we have arts and science college, they used to come May June. So we get regularly students from various parts of Tamil Nadu for internship programs. Then US, Europe, higher studies. So once you finish your undergraduation, so now there is a more opportunity for now there is a now more people are interested in doing post graduation and that too in abroad. So when you want to do abroad post graduation, we give guidance to which college in US, which college in Europe. So we are tied up with New Jersey Institute of Technology. We have sent a lot of students to New Jersey Institute of Technology. So we tell them what is the visa process, how much it costs, so what is the GRE score, TOEFL score, CGPA. So those things we tell. So suppose in computer science, which university is best in Europe, which university is best in USA. So these are type of things we provide information. So as I said, these are the three offerings. So we have resource persons. This is our company is a 30+ team. So we do onshore, offshore projects. So our resource persons are spread over the world. Some people are in Chennai, some are outside Chennai, and also in US. So technology enablement, as I said, the center of excellence, establish a center of excellence in universities and colleges. So these are the some of things we do for academia. So we like internships, we call internships, 15-day internship, 30-day internship, paid internship, free internships. So then we also conduct workshop, a shorter workshop ranging from 1 day to 5 days. Then global AI and chip design conference. So AI and chip design, these are the two important things. So now it's 2000, in August 2024, we also conducted an SRM, Global AI Conference. For SRM we conducted, even for SIRA, the year before that, we conducted a Global AI Conference. So we regularly conduct Global AI, Global chip design conference. Then orders of the setup. These are orders of the. So like maps, there was a request. So for BI. So whenever there is a request from faculty members, from colleges, universities, we provide in-person, on-campus training according to the needs. So it's all tailor-made. So what is the management requirement? What is the management requirement for the students? Accordingly, we frame the course. Accordingly, we provide the course to the students. So either we come to the campus in person or also through online. So these are three things: AI, chip design, HPC, high performance company. So these are our resource persons are from these three different things. So AI, chip design, and HPC. So these are things we are continually doing research solutions. So we are sending a lot of proposals to government in US, government in India. So these are our international key collaborators. So since our company is headquartered in California, so we have tie-up with the Ohio State University, University of Oregon, University of Wisconsin. So these are top-ranking universities in the US, and also XIS, XScale Solutions. These are the software companies. So where we send people to them. So there are people working as XIS from outside. Like, so these are the institutions. So like like SRM, Ramapuram, VIT, Shastra. So some of the colleges, universities are from Chennai, other parts of Tamil Nadu, and also in other states of India. Like for example, New Horizon, it is in Bengaluru. Then we have that JNUA, it's Jawaharlal Nehru Technology University, Anantapur. So in Andhra Pradesh. So we have signed MOUs with various institutions. Accordingly, based on the MOU, we provide solutions. We cater to the needs. What all is documented in the MOU, according to the MOU, we provide the solutions. IBM. So can you tell me what is the expansion of IBM? So IBM is a very famous company like TCS, Wipro, Cognizant. What is the expansion of IBM? So there are some students from AIML. What is the expansion of IBM? It is a famous company. Before I talk about this program, okay, I'll tell. So what is the expansion? IBM is international business machine. So it is one of the biggest companies. So our CEO, he worked for IBM for 27 years. Okay, so now we are conducting IBM career education program for all colleges, universities. Currently, we are doing this for a college in Chennai. So what is IBM career education program? So it is mainly for engineering college students. So like they have 8 semesters, they are undergoing various. So in each semester, you will have 4 or 5 papers. So what is IBM career education program classes? So you have some specialization, AIML, cyber security, cloud computing. So students can each semester there will be a paper there will be a subject from IBM where we go and deliver the course. We from Ambi Automation we deliver the course. the materials and everything, software, all these things will be provided by IBM. So they also get a co-branded certification. Okay, currently we're doing for a college in Chennai. So it is a 8 semester product. So in addition to the BE or BTech degree you get, you also get the IBM career education program certificate. So it's a co-branded. So we have various specialization. Currently we're doing AML. So what is the benefit? Hands-on learning. So you get access to the IBM website. They are the LMS. You get access to this. So any point of time, you can learn all these things. So these are some of the things we do. Okay, so AI lab. So currently we are establishing AI lab. So what is the AI lab consists of? It consists of IBM. So like IBM is a company. So IBM is like a company. So they manufacture servers, lot of things. So IBM is sponsoring some of things. Like for example, open source technologies we can get from open source. Like IBM, we get their hardware, software. They give free of cost for AI lab. So that is a from IBM. Okay. So now if you can see, so now we have data. The data has to be processed efficiently and faster in quick time. So for this, we cannot do it laptop. So laptop we have limitation CPU. So now in deep learning or GenAI agentic AI, where we need to process large amounts of data and also store large amounts of data, we need server. So we need GPUs. So this Power AI, this for example, that IBM Power AI is a software platform which runs on the IBM Power System, AC922. So we are also providing this. So mainly useful for machine learning, deep learning, all these things. So these are the special courses in object automation we provide. So we talk about machine learning because we know for GenAI, agentic AI, it does have machine learning. So Python libraries, machine learning, deep learning. So this is the foundation. So anybody wants to do GenAI, we teach few hours on machine learning, like Python libraries like Pandas, NumPy, Matplotlib, CMOP. So these things we cover since it's very essential. Now we are in an era of quantum computing. So we also provide courses on quantum computing, cyber security. So we are partners of Microsoft. So you know cloud is very essential. So in Microsoft Cloud, Azure, we have a lot of resources. For example, if you want to become a data engineer, so that also we provide a 30, 40 hour course. So a lot of resources are available in Azure. These are some of the things we do. I will talk about this in detail in another session about data engineering. So I'll be talking about data after our speakers speak. What is data engineering? What is a data engineer? So what they do? So what are things you need to learn? All these things I'll talk about later, maybe another 40 minutes after on data engineering. So these are the things we do as an OA. This is our profile. So Mr. Ganesan Narayanasamy is our CEO of our company. He's in California. So this is our development center in Chennai. So ours is the 30% team. So we do three things: chip design, AI, quantum computing, HPC. So thank you very much. Do you have any questions? I just gave you a brief introduction about what automation does. As we proceed, we can ask any number of doubts. So
Thank you, Madan sir. Now I invite Rahul. He is working software engineer here. He is going to delivery like a Gen AI speech and like development projects.
So good afternoon all. So I'm here to give a brief intro to how AI is evolving and how AI is going to evolve. Okay. So to start with, so let's start with the past. So in the past, we follow like rule-based business logics for building software applications. Okay. So now, like at present or in the futures, what is going to happen is system is going to learn and it's going to reason why I take those steps to make my actions, and it's going to act or build your applications or anything you require based upon your task. Anything it's going to be taking action of. Okay, so um, yeah, so in the present or in the futures, like many industries are going to be transformed because of AI. Like it can include education, software engineering, or medical, law, finance. Like every department or domain is going to be AI is going to be implemented in every field. Okay, so how it actually evolved. So as I already mentioned, we followed a role based, like a if or else based business logics to build applications. So then later we moved on to machine learning, so which is part of AI, like subset of AI. So where like we provide data and machine, like we'll be using algorithms like either from supervised or unsupervised. So using any of those algorithms, like we are going to train a model. So using like seeing data, like it's going to learn a pattern. So from that it's going to predict an output when you give a unseen data. So from that, we got introduced to deep learning. So where deep learning got like neural network, which basically helped for deep learning. So which is advanced model training. So with machine learning, we were only able to train structured data. So we want to process and model, train models with unstructured data. So either it could be from text or numbers or images or videos. So deep learning can help with that. Okay, so we have several algorithms over there, like feed forward neural network, recurrent neural networks. So then we have transformers and yeah. So in deep learning, the AI could probably predict the missing word. Like the older models, like BERT or BERT to vec, so they aren't capable of get to know the meaning of the whole context of a sentence. Okay, so yeah, so a bunch of research scholars from Google, they came up with the idea called self-attention mechanism. So which led to today's era of AI, like which is generative AI. So what this self-attention mechanism has helped us do is to understand the whole context of a sentence. So to for AI to generate the output for a task or text generation or any summarization, it need to understand what is the context of the whole sentence. So the self attention mechanism help to do that. Like how one word in a sentence can contribute to other, so that I can understand the whole context of a sentence. So using that, I could predict my next word in my output. So that is where a like generative AI like evolved. So in generative AI, like we have like many topics like fine tuning or retrieval augmented generation. Like we like not only using those model or applications are necessary. We also need to evaluate those model or like whatever your application you are using. So they are like it is also part of a Gen AI. So from there, it evolved to agentic AI because these LLMs, they can only um, they can only respond to your question, but eventually they cannot perform any actions. Like they cannot go to a website and book you a ticket or any perform any actions. So from there, now we got introduced to agentic AI. So where AI could perform actions based upon your task, and from there we have single agent systems or multi-agent systems, like how we can connect each other agent for orchestration, like how they can communicate with each other so that there is no mismatch in communication and the task gets completed properly. So and these generative AIs, they don't have the capability of memory. Okay, so using like in terms of agentic AI, we can also implement like either a short-term memory or a long-term memory. Okay, so these agentic AI help with those, and from there we have autonomous core. Like we have many autonomous products nowadays. So generative AI, the power and the ceiling. So what is powering the generative AI and what can bring down the generative AI? So like when I say generative AI, it is basically large language models. So these large language models, they are trained with millions of billions of data available around the world. So they go through a process of tokenization. So where like um, once your data are collected, they will be going through the transformer. So where the first step is tokenization. So where we split your sentence or a word into tokens, and each token will be having a unique ID. So from there, it goes to uh, embeddings. So in embeddings, what we actually do is we will be having an embedding model, so which will help us to convert all those tokens, which are in terms of letters or words, into a numerical vector representations. Okay, so these vector these embedding models, right? So they have like each model have like particular dimension. So some model may have 384 dimensions, some model may have 512 dimensions. Okay, so what this embedding model will do is, so for each dimension I want my word to be represented in a multi-dimensional space. So let me say, um, like I'm having a word called text, and the word text will be represented in the 384 dimensional like vector. So each dimensional space, no, it refers to a, pronoun, verb, and so on in the multi-dimensional space. Okay, so all these conversions will be done with the use of embedding model, and so from there, it goes to the self-attention mechanism where it learns the context of the input, and after that it comes out like it passes through another layer, multi-layer perceptron. So where it goes to either a 12 layer or a 24 layer based upon the model, and it gets learned whether the sentence is a pronoun, verb, or a noun. Does it refers to a person? Does it refers to a like any being? So from there, now we will be calculating softmax for the next prediction. So that is how now these large language models work. So after that, we have retrieval augmented generation. So retrieval augmented generation, when I say, like it is having three words. One is retrieval, another thing is augmentation, and after that generation. So what happens in this RAG is, so let's say my LLM model, it doesn't have a knowledge about my company, object automation. Okay, so I'm asking the LLM model something related to my company, and it says I don't have no knowledge. Okay, and what I can do is with the help of RAG, I can set up a system like having an external data source which can have data related to my company. So using that, I can connect to the LLM so that whatever question I ask to the AI, So it goes to my external documents and it gather those details. And what happens in augmented generation is sorry. Um, so in augmentation, we will be setting up a system prompt where the retrieved context plus question and the instructions how A should be acting will be implemented. So that part is called as augmentation. So from there it goes to generation. So all this augmentation part with the retrieved context, question and instructions will be going to LLM. So using those, LLM will be generating a response. Okay. So this is how RAG will be working. So when my LLM doesn't have a like proper knowledge regarding an organization, I can use RAG. So what can bring down an LLM? So first one is hallucination. So hallucination means when like the LLM models, they don't have like a prior knowledge. Like if I ask a question, it will be confidently it will be giving me with an answer, but the answer will not be related to my question. So confidently it will be bring up an answer bit which will be looking as polished, which is related to my question. But once you dig deep into the answer what it got, so it won't be related to my question. So that is what hallucination is. So hallucination can be avoided with either using RAG or prompt engineering. So when I talk about engineering, so it is now kind of a language which bridges the gap between human and AI. So whatever we are communicating to the AI, it all goes in the form of prompts. Okay. So a prompt, we should have a clear instruction, context. Either if we have input data, that can be also included, and with that we can also intimate with the output format. Like I want in terms of JSON or a table or a document like PDF or any table format. So these can be included while writing a prompt. And prompt engineering, it has few types. So one is zero shot prompting. So like zero shot prompting is telling the AI system to act with its pre-trained knowledge. So I'm going to tell the LLM, like I'm basically going to assign the LLM with the task. I'll be telling the task, the context. If I have an input, I'll be having the input and what should be output. So with those instructions, it's going to act with its pre-trained knowledge. So that is called zero shot prompting. So after that, we have another type called few shots prompting. So few shots prompting, like we'll be giving few examples to the AI in terms of prompt. So what this AI is going to do is it's going to get the context and the pattern from the examples. So from understanding the context and from the given examples, it's going to act for my task. So that is few shots prompting. So after like another technique we have is chain of thought. So let me say like you are working related logical problem solving or any problems resolving mathematical. Um, so mathematical. So you can use chain of thought, so which enables step by step thinking. Like what formula is used, like what are the calculation methods used, like how is my output is calculated. So using chain of thought, we can do that. So and another limitation is it can like few models may have limited reasoning. So few LLM models are specially trained for reasoning. Like you can see the model name with like Llama 3.1 8 billion reasoning model or reasoning enabled model. So likewise, few models only trained for reasoning and no real decision making. So as I mentioned, these LLMs they don't have real decision making sense. Where that's why we move to agentic AI, so which will help us to make decisions and short-term memories. And similarly, it doesn't have any memory context. So also we need agentic AI for that. So these are the things which can bring down an LLM. And yeah, so the code like difference between Gen AI and Agentic AI. So so the main concept of Gen AI is to generate a new content, and Agentic AI, its main task is to make real-time decisions and get your task completed. And operational mode, it is like LLM is more like prompt dependent. Like whatever you say in the prompt, it's going to only do that. But agentic AI, like it's goal oriented. Whatever the task you're implement, like given to the agentic AI, its goal is to finish the task. Like how many refinements it takes, but the end goal is I need to finish the task. So that's what agentic AI. And memory context, LLMs, no, they don't have a huge memory context. Like whatever the convo we have, all those are calculated in terms of tokens, and each model have a context length depending upon the tokens. Like it depends upon the company. Like few models may have 200K context length, some may have lesser than that. It depends upon the model you are using. But agentic AI, like now they can handle both short-term memory and long-term memory to grasp your context. Or if you say like next time when I come to you, like remember these preferences, so it can also store them in form of JSON, and next time when you come back, it can remember those. And capability, so generative AI, like it's a next token prediction, like whatever the prompt I'm giving. So based upon the prompt, it's going to get me the output. But agentic AI, it can use API like weather calling tool, or it can connect to database for data retrieval, and it can like we can use like web search tool like DuckDuckGo, and it can also like go to your local system files and take any file and work on them. So agentic AI and then AI, these are the difference. And anatomy of an AI agent. So as I already mentioned, agentic AI, like they are goal oriented. They act upon your goal, and they have the capability to use tools and plan. Like what basically happens when an AI agent is working is, first it does the planning, like what are the steps I need to take to complete the task. So after that, it makes the reasoning why I made like why I chose these steps to complete my task, which basically gives a reasoning. So after that, it makes the actual task, like whatever you're assigned to. So that's how agentic AI actually works. And yeah. So whatever the output you got from the agentic AI, we will be having an evaluator at last. So which is going to evaluate whether the task is completed in a proper way, or else it goes back to a refinement. Like again, planning starts. Again, it reasons why I took these steps, and after that, the process continues until we have a proper output. So that's how no AI agents work. So yeah, this is what I like explain now. We'll be having a user a request, and we will be having a planner agent. So which like plans what are the steps I need to take, and after that we have task decomposition. So if you have multiple tasks injected into a single prompt, they are going to be breakdown into part to part. So they will be done one by one. So for completing my task, what are the tool selections I need to make? After that, your real execution is going to take place, and they are going to update them in the memory to like maintain the memory context, and we will be having the final response. So this is the agentic workflow. And while the execution is happening, if we have any errors, like it's going to go for self correction. Like what are the self corrections that are need to be made. So again, it goes to the planner agent, and task is going to be broken down. Tool is going to be get selected, and they again will be having an execution. So the agentic AI infrastructure. So the application stack, it basically have the like the frameworks or dependencies which we are going to use to build these agentic AI systems or Gen AI systems. So when I say frameworks, basically LangChain. So LangChain can be used for LLM orchestration or any tool calling. So and we have LangGraph. So LangGraph is a main agentic AI framework like which helps for maintaining the state of a agentic AI, like how it should travel from planning to task decomposition and tool selection and execution. So all those happen in the form of graph like nodes and edges. Using those, like LangChain will be providing those graph, and using those graph, these agents, they remember this, their stage and orchestration can happen. QA and AutoGen, they provide agentic AI tools. So using those, we can like yeah, like we can either instead of having a separate function for tool selection, we can use few libraries from QA or AutoGen. Using that, we can do our task. And cognitive layer. So basically, the LLM layer. So where your LLM is going to be staying. So these agentic AI, they are capable of only taking real-time decisions. But who is helping those planning or decisions, like reasoning, is the LLM. So without the LLM, agentic AI, they cannot act. So we need the LLM, and we have the memory layer. So where we can set up the short-term or long-term memories. And yeah. So another important concept in GenAI or agentic AI is vector database. So as I already mentioned, all the data, they will be converted in terms of embeddings. So and they will be represented in a multi-dimensional space. Okay. So the normal database, SQL databases, they are they are capable of storing data in terms of rows and columns, but we need to store these embedding in multi-dimensional space. So these vector database are helping to store data in terms of multi-dimensional. Okay, so these are powered with ANN search, so which can retrieve like whatever the question you are giving, the retrieval can happen within 10 milliseconds, and it can also be paired with GPU. So the retrieval process will be done with low latency, and we have the ops and deployment layer. So basically, setting up the Olama or any LLM inference tool like VLLMs or Olama. So that's where ops and deployment layer is for. Either if you have Docker or Kubernetes for containerization and um, maintaining the load. So all those will be present in the ops and deployment layer. So these are like where the industry is using AI for, like in software development, like AI coding assistance, automating testing, and in finance and HR, automated invoice processing. So likewise, AI is transforming every industry. Yeah. So So, like, I have a sentence over there. Like, AI will not replace humans. Humans using AI effectively will replace humans who don't. Like, how many can relate to those sentence? Like, how many can you agree to that? Are you going to say yes or no? Why? Why are you saying yes? Why do you say like AI is not going to replace human? Sorry. Okay, sir, but at some point it doesn't need human, right? Like what we saw in the movie, right? Once the robot created, it can create the robo itself. So likewise, it can happen. But why do we say like AI will not replace humans?
So in AI, where the humans are build the AIs, right?
Yeah.
But where the AI do not have the emotions on how the people are being suffering from these situations. So
Okay.
that AI are able to understand the emotion of the human.
Okay.
So that basically humans who have the courage to learn about AI so that
Okay.
they cannot able to do this.
Yeah, absolutely. So yeah, even though we have AI, we need a human in the loop to manage them. Like whatever, um, like we need human. Like it's going to be like if 1,000 people are working, that's going to be reduced because AI is going to take care of them. But we need a human in the place where if it is stuck or if you need to add any new thing to the AI, like we need human for that. Okay, so however, we will be still in the play using AI. So who is going to be the top in AI is going to rule the industry. Okay, so from agentic AI, there are different pathways the AI is evolving. From that, one I took is AJ, which we are basically involving in. So what we basically done is, if you are from the background of chip design, you might know FPGA board. So using those FPGA boards, we were able to run AI inferencing inside them using like they are like chip which are capable of consuming low energy and the latency in data processing and data like whatever the data you're processing inside a chip it doesn't goes out. So all these are done using those FPGA board. Okay, so what we basically done is, so we trained a machine learning model outside the environment of FPGA board. We extracted the weights and biases of those machine learning model, and we transported that to the FPGA board, and we set up the system with the rule-based logic, and we were able to do with the help of rule-based logic, we were able to detect object using sensors, and we also able to predict house price prediction, spam classification, and many other use cases. And we were also able to run LLM model using those FPGA board. So, as you know, the prices of RAM, memory, GPU, CPUs are going up, but not to overcome that, this HA like will be a proper requirement, like because it has low latency, like it can be. It doesn't need internet and enhanced data privacy and faster and localized system. So you can carry this type of board wherever you go, and you can use AI. Okay, so that is one major advantage over there. And now going forward, using this FPGA board with help of AI, we can build autonomous intelligence systems like a drone, or even it can be used in industries. So likewise, it's going to be evolving, and we are also researching what can be done using edge devices plus AI. Okay, so the future is not just A that answer. The future is A that acts. So, do you have any questions here? Any doubts? No. Okay. Thank you.
Yeah, thank you, Rahul. So any doubts from student side, from Agentic AI and Gen AI? Most of the students doing internship here, like Gen AI. Any doubts? No doubts. Aruni, what about you? Okay, fine. Thank you, Rahul. Now I'll going to invite the Padma ma'am. See, Object Automation Sister Concern Company Extreme Academy of Learning. Their students 11th, 12th grade onwards, they are learning Gen AI and AI. Okay, now I invite Padma ma'am to deliver some programs what we are running in ZAL.
Very good evening to one and all here. It's very pleasure to meet all the professors who are coming and spending their valuable time with us. So, based on I heard about a few points, whatever in this technique, it's really helpful. And one of the fellow is really tells about the difference between AI and the human intelligence. Yes, the emotions where we have that emotions as a human, our brain is talking about all the emotions, but they don't have the emotions. But where they replace the humans in driverless cars, even the surgical part in the medicine industry, the AI is doing the surgery, everything we are seeing the all over the world, the AI is now dominating. So as you Gen Z kids, it's the right place for taking up the decisions and taking internship with our ZAL team. It's a wonderful thing because these people doing the demonstration here and your decisions will make you your best future leaders. Apart from this AI team, we are running up ZAL with phonics, where that school students they are learning up the better communication and their leadership qualities, everything we are having phonics class and abacus and Vedic maths. So many things we are tying up with that one, and it's great opportunity. You are taking up the decisions, learning up of AI. It will give you a very best future. All the best, and thanks for all coming to attend this technique. Thank you.
Thank you, Padma ma'am. Now I invite Varuni. She is SRM Ramapuram college student. She is Katangaluttu. Okay, she is going to talk about her internship experience. She is learning Gen AI here.
So good afternoon everyone. So my name is to introduce my name is Varuni. I am pursuing my BTech in SRM KTR as ma'am said. So I came here to do my internship, 1 month internship, where I wanted to learn all the new technologies which would be helpful for my career. And along with that, I'm also doing a Gen AI course. Gen AI is I think it's the fastest growing technology right now. So I also want to update with the Gen AI and agentic AI skills. So from my perspective, in today's generation or in current scenario, just learning one skill and being professional in it is okay. But learning every skill and trying to specialize in a particular skill will help to it will help us to get exposed to more opportunities. So and also the team has helped me and supported me in developing a automation system where I would try to create content for a company and it would automatically get posted into LinkedIn and Instagram. I'm trying to build that, and Rahulana has also helped me in creating it. So I'm looking forward to learn more AI technologies and improve. Thank you.
Thank you, Varuni. Next intern from Stella Maris College. She is completed BBA Rimsha. She also doing data analytics course here as well as she is learning AI.
Hello everyone, I'm Dinsha and I'm from Stella Maris College. I'm a recent graduate from BBA. Even though my background is from business, I think the technical skills is really blooming in the upcoming years, and that's why I joined the training over here so I can bridge my gap between business as well as my technical skills. I'm currently training in Power BI and SQL, and it's really very informative and I'm learning a lot. There's two things which I like from the training over here. First thing is that I can study in my own space. There's no pressure, and I really understand the concepts really very well. Second thing is the training staff. They really are very approachable, friendly, and they even motivate us in such a supportive environment of studying. it's really good. And I look forward to like applying these skills in my real life scenarios. Thank you.
Thank you, Rimsha. Next, I invite Mr. Kruba, Chip Design and Emerging Technologies. He is going to talk about hardware related stuff.
Yeah, good afternoon, everyone. I will talk about the chip design, like what works we do in the company. So, like in our company, we work with the full chip design flow from the RTL design to the building a chip layout. So you can see here. So we work with the Power IC architecture. So you all, if you are aware, have anyone from ECE side? Anyone from ECE? Here. Okay, so basically, we have a process been running in our system, right? Everything will work on a specific system architecture. So if you can see the process, like what we work with the Intel AMD, that will work with the architecture. So similarly, we have an open source architecture named the Power ISA, the instruction set architecture. That's what we work, because here this architecture is been available as an open source, like so anyone can work, can access this architecture, and you can build your own processor out of it. Okay, so as Madan sir has been already discussed you about the Open Core Foundation. So from the Open Core Foundation, we just collaborate with the IBM, and we are just using the Open Power ISA architecture to build a processor. So you can get access to this Power ISA architecture, and we have several processors from this architecture. One named Microwatt. So that is one tiny CPU processor. So you can get access to the CPU processor, and where the students or like the researchers can get into like how the processor has been working. So you can get through like how the instruction works, the memories and peripherals, how they interact. So then you can modify the codings of the processor, and you can build from that your own processor. So that's one thing, like where the Microwatt stands, like that is a CPU processor. Like you can enhance the code also, like by adding some sets of instructions to that processor. Then as a part of a project, we do the we have a FPGA board called RTK7. So that is similarly like a chip, like ASIC chip, that what we have in a system. So but this FPGA board will help you to reprogram it. So like before getting into the main actual chip, we just use that FPGA board to flash this code like this Microwatt and check how this working. So we just use it for simulation, that is for to write the explains to verify the codes, and then like FPGA prototyping, where we use the board like here we have RTK, so that is a Xilinx FPGA board, and we are also tied up with some university like Oregon, like where we have some boards that has been available in the server also. So once we get access to this course, like we will give you the access to the server, so then you can log into the server and access the FPGA board that has been available in the server also. Then that covers you the front end part, like where how we write a code to the processor and how you test with the simulation and like with the help of the FPGA board. If you come to the back end part, like we have the physical design. So if you go to the back end part, like we have this stages like from synthesis to the DDSP flow. So this is like you just create a layout for a chip. So before we manufacture a chip, we have to create a layout. Like how we build a building, like we are like designing the architecture, right? So similarly for the before we build a chip in the foundry, like in the fabrication, so we will create a layout. So to create a layout, we have some stages like synthesis, floor planning, placement, CTS, clockwork synthesis, like that. We have some 5 to 6 stages to then you will get a final layout like that in the right hand side you can see, right? So that layout that we will send it to the factory and they will make a chip out of it using that layout. Okay. So as a physical design engineer, we have to design a chip. So like how I said, like we have the open source code like the microwatt. Similarly, we can get a processor code. Then we have to create a chip for it. So that will be varying from the size. Like currently, IBM has 2 days before they had launched a chip less than 1 nanometer size. So all this can be that we develop from the physical design using those flow. Like in the market, like we have some tools like Cadence and Synopsys, and here like we just teach you with the open source tool called the Open Road for the students to get understand like how to build a layout and all. Then as in the research work, like we are also having another project called the A204 that is also similar processor like the microwatt. So where we collaborate with the industry professionals like and the research experts like every Saturday, and like we will where we trying to upgrade the architecture of the processor. So like we just used to select the students and like we work with this professional and like we are just trying to upgrade the architecture of the processor. That meeting will be happen every Saturday. Uh, yeah, so that's this is the full course like we offer, and we also give trainings to the students and industry professionals too. And like we also conduct a hackathon previous year, so where we just select the top 3 winners, and like we were now making a chip out of it. So likewise, similarly, we had planned now this August month. I think like we have planned another one hackathon with type with the IIT Bombay using this open source architecture. So like we will just give you the open source architecture, then you have to come up with your own idea. So if that is been good, like we will selected in the top 3, like we will make a chip out of it. So that's what we plan. So with the help of we type the chip foundry, and we just in the A204, as I told, like that also has been funded by the European government. That also has been support in on site. Yeah, so that's in the future work. Like we have some like upcoming hackathons. That is one is with the tie up with the IIT Bombay. Yeah, so that's it. The overview of like what we do in chip design. Do you have any? No? Thank you.
Okay, thank you, Prabha. Next, I invite Mr. Rajendra from SRM. He is doing intern here.
Yeah, I'm from graduate. I'm from SRM Kedia. So I'm recently graduated in SRM. Like I completed my BTech on EC department. So I'm recently joined as an intern here for the 6 month intern to full-time employee here. So now I'm working on chip design related stuff. So in the chip design, I'm working on the front end side. So the process architecture side. The process architecture, I'm working on both microwatt and A204. The microwatt and A204 are basically built using the OpenPower ISA, and the OpenPower ISA it's from the IBM company. So using that OpenPower ISA, the A204 and microwatt is built. So you can use that microwatt and A204 repos are there, GitHub repos. You can use that. You can use that, and you can build a chip by your own. So, yeah, I'm also working on the A204 presently. In the A204, we are in the older version of that. So, for upgrading that, we have some instructions which are there in OpenPower ISA. That's are not there in the older version. So, I already implemented around 3 instructions and 5 universal instructions. Then, I successfully ran with 0 violations in that. So and now I'm working on a microwatt. I'm studying in depth in the architecture about the microwatt, because the microwatt and A204 is built like using 5-stage pipeline. So so for understanding that, we have to more go in depth of the architecture side, and after that I will go to the physical design stuff like some entire RTO2 GDS from the using the open. then will like I want to will any project related to that from next week. Thank you.
Thank you, Rajendra. Now I invite Wales University students from chip design team. They are also doing intern here.
Good afternoon. I'm myself Kirtana. I'm a student of Wales University. I'm an intern at Object Automation. I'm doing internship on the topic of VLSI chip designing. At the beginning of the internship, I did learn a lot about microwatt, and now I'm focusing on learning about A2O core processor. Um, I did. I did wrote some test bench and designs on logic gates and some arithmetic operation. And currently, I'm focusing and studying in detail about A2O instruction and test benches. Thank you.
Thank you, Kirtana. From Wales University, another student.
Good afternoon, everyone. Myself, Mahesh. I'm a ECE final year student at Wales University. Few weeks back, I was working as an intern in object automation. During this internship period, I was working in A2O code. Unlike the small digital circuit as we did, A2O code is a complete entire industry level processor. It has multiple modules integrated in it, and I also create a test bench for logical OR operation, and I also check and verify it. Mm, uh, that's it. Thank you.
Thank you. Now I invite Mr. Madan sir to talk about data engineering.
Chip design, and we had reviews from various interns and who are taking the courses from us. So the advantage of taking GenAI course from us is we have collaboration with University of Oregon. So we provide GPU access since getting AI GenAI requires GPUs. So we are providing GPU access. We are tied up with we have student ID. So we have the access tied up with the University of Oregon. So who are taking courses with us, we provide access to University of Oregon GPU server. And also, I just want to talk about chip design. So recently, Wales University they conducted a workshop, 5-day workshop, and also last year, it was in October, we conducted a chip design workshop in SRM Katakultur. It was a 3-day workshop. So we invited people from IBM. So one Peter Rafti is a famous scientist. So he came here from all the way from US. And also Karan sir was there. On the third day landing function, he was there. So it was a 3-day chip design workshop. So Kirwanaji and Jagat, so these are our chip design engineers. So they conducted this workshop. So recently these interns, so they were selected out of the 50 students. So we conducted a 1-week, 5-day workshop on well simplicity. So these are 4 students we picked up. So free internship with providing them. Yeah. So before I go into data engineering, so we know, so data is the oil, they say oil or something like that. So like I have, so most of the students are for AI/ML. So data scientist, data engineer, then Gen AI engineer, AI engineer, machine learning engineer. So those days it was only machine learning. So people who learned machine learning, Python libraries, Python, they were able to become a machine learning engineer instantly. So now even for them, so like Rimshot, person who spoke about business analytics of Shannon Harris. So like BI tools, business intelligence tools like Tableau, Power BI. So when we want to do create a dashboard report. So what is the use of BI tools? We create reports and dashboard. So to create this reports and dashboard, we need to have a clean data. So data has to be clean. So garbage in, garbage out. So data engineer, they play a very important role. So what they do, they clean you have a raw data. The data can be an Excel file, CSV file, a cloud, it can be in a cloud. So what they do, they take that is the source. They take the data, they do some transformation. Like they say ETL or ELT, extract, load, transform. So this is one of the steps they do, data engineering. So data engineer, as a data engineer, you have to build pipelines. So I'll just go through a few slides. For data engineering, the knowledge of Python is very essential and intimate knowledge of SQL is very essential. So most of the data will be in form of tables. So as he said, table, rows and columns. So when you want to fetch a query, like you have to use all the commands. So like insert, all this. So your knowledge of SQL is very essential. So since most of the people are from AI, ML and CSE, so it's very essential to know SQL. Whether you be a data engineer or not, or a data engineer, or a data analyst, or a Gen AI engineer. So knowledge of SQL is very essential. At least an intermediate knowledge of SQL is very essential, and Python, basics of Python. Okay. So this is very, very important. And also a cloud knowledge is very important. So all this data, mostly it is in the cloud because we need servers, GPUs and all. So now most of the enterprises, they are having the data in the cloud. So a knowledge of cloud, for example, where is this data stored? Something called storage account. So 10 to 15 hours of knowledge of cloud. So what are the resources we need to know? Few things on cloud is essential. So I'm just giving a tip for AI, ML students, CSE students, SQL, Python, cloud knowledge is very essential. Whether you for any to be in the market. Okay. So I'll just talk about what is data engineering. So basically, data engineering is what you are designing, constructing, and managing systems. So you are creating a system infrastructure that you design and manufacture and collect. So what is the purpose of designing the system? You want to collect the data, store the data, process the data, transfer data. So to do this, you have to create some systems and infrastructure. That is what a data engineer does. That is the data engineer does. So data is compared to gold. So how do you get the gold? Gold is buried in the sand. So you pick the gold, you you mine it, you refine it, you get the gold. Similarly, you have a raw data. With the raw data, you cannot infer any insights or decisions. So the data has to be, you may be having missing values, you may be having some unwanted columns, you may be having some unwanted data. So you want to drop those columns, drop those rows, fill those missing values. So all these pre-processing steps have to be done before you do any other business analytics or any for machine learning engineer or data engineer or Gen AI engineer. The data has to be good. So these are the things I do, data engineering. So data engineering, it involves a series of steps. Software engineering, data architecture. Like simply we saw an architecture, like when you build a apartment or a house, you have an architecture. Similar to that, data engineering. So these are things you need to know. Software engineering, I told Python, SQL. Then data architecture, database management. So everywhere, every data will be stored in the form of tables, rows and columns. Because when you want to store large amounts of data, it has to be in the form of tables, rows and columns. That is database management. So ETL, I talked about ETL. So you have extract data from the source. Then you do some transformation. Then you load it to the destination. So that is the main thing they do, ETL. So source to destination. In between, you do some pre-processing transformation. So these are things which can be automated. So what is the purpose? Mainly for data science and business intelligence. So when you want to create a dashboard or a report or a machine learning model, so your data has to be like good, and only when your data is in clean, good structure, you will have a great good model. So garbage in, garbage out. A good data provides a good model. So this is a typical data engineering architecture. So first thing is you collect and ingest data. So wherever be the data, you have to first collect it. Then in data engineering, there are three terms: data lake, database, data warehouse. So I talked about to few people about data lake. Can anyone tell me what is data lake? So these are three things in data engineering or anywhere. You talk about data lake, database, data warehouse. What is data lake? So I think so I shared this to few of the interns. So there are some three types of data. So you have a structured data, unstructured data, semi-structured data. The data lake, you can store any type of data. In database, only structured data, rows and columns. Whereas in data lake, whether it's an image file, video file, audio file, so JSON file. So all types of data can be stored in the data lake. Then database, so where you do all these things, transactions like Amazon, Flipkart, those companies, they have a lot of tables: customer table, product table, transaction table. That is database. Then when you want to do some analysis, you don't take data from you don't disturb the database. You take a copy of the database tables, or you pick only those tables which you require. That is called data warehouse. So data engineering, mainly they work on data warehouse. So they do analysis with the data warehouse. So basically, in data engineering, they create a pipeline. Like we have in our house, we have from the tank to the kitchen or to the bathroom, we have a pipeline. So water goes to various places in our house. Similarly, the data engineer, they create pipelines. So what is it? From one location to another. Mainly the pipeline is nothing but it is an automated process which goes from one location to another. So mainly we are moving data from sources. The source can be a database, an API, and we are moving this database into storage systems. I told you data warehouse. So only from the data warehouse we can take data and create a machine learning model or a dashboard or a report. So these are things I talked about data engineering. As a data engineer, we need to know what is a data lake, what is a database, what is a data warehouse. So data lake is place where you store all types of data. First thing is you move your data to data lake. Then from data lake, you take only those data that you want to process. That is data warehouse. So like data warehouse is like centralized repository. So the data warehouse and database, the data will be in the form of tables. In data lake, it can be in any form, but in data warehouse and database, it will be in the form of tables. So these are the key components of data engineering. So data collection, you collect the data, then you store this, then you do some transformation. So you say ELT or ETL. So now, previously we used to have data lake, database, and data warehouse. Now we have a model that is combination of data lake and data warehouse. That is called Lakehouse. So I'll be talking about Databricks. So Databricks is a company, AI company, where they have created this. We don't need to store data in data lake, then take data from data lake. So you have a platform where that platform acts as a data lake as well as a data warehouse. It's called Lakehouse. Lakehouse architecture. It is from Databricks. So these are some other things. So you have any questions until this point about data engineering, So once you know data engineering, you can become a data engineer, because data engineer, everywhere's data. As the data keeps going, the knowledge. So once you have a career in data engineering, it fetches you a lot of things. So knowledge, money also. Okay. So data engineers can travel around the world. You have a lot of opportunities. But thing is, you need to know SQL, Python. Few things you need to know to become a data engineer. So you are from AI, ML, CSE. Some other students can take data engineering as a career. So I think so. We are in the third year. You have 2 more years, so you can start learning more SQL. You can do all these things. You can create projects. So what is the use of data engineers? They work closely with data engineers, data scientists. So if data engineers, they don't do anything. So they do all this work for some other people, like data scientists, analysts. So for them to create that model, to create the dashboard, data engineers help them. So they are the ones who clean the data. You have a raw data, they are the ones who clean the data. So why data engineering is essential? So in today's data-driven world, so organizations, they rely on data. So when you want to make profits or when you want to optimize your resources, all these things, it can be only data-driven. So all these things have to be done on data, based on data. So data engineering plays a very important role in cleaning the data. So you can see most of the raw data will be messy, incomplete, and fragmented. So as a data engineer, we all do this. So what is the future of data engineering? So future of data engineering is very positive. So, okay, data engineering in the next 10 years, there will be more opportunities for data engineers. Okay, so the future of data engineering, you can see as data continues to grow in complexity. So the data grows in complexity. So as a data engineer requirement is more. Okay, so this is one of the career options you can consider at this point of time. Okay, so I told you. So this data lakehouse. Previously we had data lake, database, data warehouse. This data lakes, they have created a model, something called data lakehouse. Lakehouse is something like a combination of data lake plus data warehouse. So that's a platform, Databricks. So we also provide course on Databricks. So 30 hours course. So like companies like Microsoft, Databricks, they are providing certification. So if you get the certification, it will be very valuable for your placement. So learning is one thing, taking a certification is another thing. Okay, so but first when you learn only, you can go for the certification. So this is the certification for the data engineer provided by Databricks. Databricks, they have tied up with Azure, GCP, and so thank you very much. Do you have any questions?
Like that, not a one should be there. We expect lot. At this 30% has to be increased to 70%, and then it should be converted to 100% through this kind of area. So best wishes to object automation and for all the students. Thank you.
Thank you.
Thank you.
So dear students, can you share your inputs? So what did you gain from this thing? Just say a few words.
Good evening, everyone. I am from Aarti from DMI College of Engineering. I am studying final year BE Computer Science and Engineering. Then Object Automation collaborate with the IBM and provide me a career educational skills program to DMI students. That is very useful for us, and that is improve our career and gain knowledge about that. That is very useful to increase our career growth in IBM. Then Sir explain about the internships in our company. That is very useful for us. Thank you for this opportunity. Give us to my professors. And thank you for.
Yeah, thank you. Now I invite SRM Vanillai College of Engineering.
Good afternoon, everyone. I am Prem Kumar. As I am currently studying third year BTech ADS in SRM Engineering College. Today I came here to attend my test for intern and get an opportunity. If I get an opportunity, I can do better. Right? While attending the test, I have gone through more of the problems that I have lagged in some of the aptitude and in coding. And if I select or not, it's not a problem, right? But I get and gain knowledge that where I'm lagging in the questions and where I need to improve myself. And as a grace point, I get to attend this meet and I get knowledge about how the data engineers are building up and how I need to improve myself in the data engineering. And I have gathered additional experience about how chips are working. Only we are data science engineer, we just go focus on that only about the software. But in an additional way, if you gone through chips, we can able to know about how the chips are working, how the internal processes are being working, so that we can able to gain more knowledge on it. Thank you.
So thanks for sharing your views and opinions of this tech meet. So with this, we're coming to the end of this tech meet. So I'm, as a word of thanks, I thank all the professors from SRM and all the students, intern students from various colleges for coming and spending these 2 valuable 2 hours here at Object Admission. Thank you, man. Thank you all students. I hope it made some difference to you. Okay. Thank you. Thank you, ma'am.
I request the students to come to give the technique feedback.
Okay. That's okay. You want to take it?
Now we have one more students also give opportunities. Can please come down.
Good evening, everyone. My name is Kavya and I am from Nehru. I have continued for past 15 days internship on generative AI at Object Automation company. I have gained lot of hands-on practices and knowledge about LLM models and prompt engineering, so that I have eagerly waiting to work on more projects. Thank you.
So yeah, I thank everybody. So now, so most of the students, when they ask, they are voluntarily coming and speaking. So communication skills is very important. So now I'm now 50 years old. So when you at the age of yourself, the old people. So at least I thank all the people who are coming and speaking. So appreciate that. So communication skills is very essential. Okay. So you don't aim for perfection. Whenever you get some opportunity, come and use the opportunity. Okay. So whether they're calling you to speak or whatever task they give you, don't aim for perfection. Perfection will come automatically. So do the task. Okay, whenever ma'am or anybody giving you some task in your college, ask to speak or ask you to create a project, take initiative. So only by doing various things, you can develop all these things, social skills, all these skills. Okay. So you can become a president. So do not think about this. We are from rural or from a city and all. So from our sir is a US president from Chennai. So there are a lot of people I know from Tirunelveli, rural village, they are in US. So wherever you may be born, whatever you're doing, definitely you can reach these tasks. Thing is that continuous learning, effort you have to put, hard work. Okay. Do not compare with others. You compare yourself. So I want to be, how good you want to be. You compare with yourself, not with your colleagues or anybody. Okay. Thank you.